Let's take a look at the applications of linear inequalities. To translate the inequality phrases into the mathematical notation, if we have the phrase as x is no greater than the quantity y, when x is less than or equal to y, x is at least as large as y, that means x is greater than or equal to y. Y exceeds x, that means x is less than y. For this example, in the class in which the final course grade depends entirely on the average of 4 equally weighted 100-point tests, Lisa has scored 75, 94, and 95 on the first three. What range of scores on the fourth test will give Lisa a C for the semester, an average between 70 and 79 inclusive? Assume that all test scores have a non-negative value. Express your answer in interval notation. So let's get started with identify or define the unknown. Our goal is to find the range of the scores for the fourth test. So let x be the score on the fourth test. And then the average of 4 tests going to be the sum of all 4 of them, 75 plus 94 plus 95 plus the last one, which is unknown yet, so which is x, all divided by 4. And we're gonna find the range of the scores that will give Lisa a C. The C means the average between 70. So the C grade will be in the range of 70 and 79 inclusive. That means include these two numbers. So the average will be the middle expression. So to set up, let's write in the better handwriting. Average score. So then to fill in or complete it in the compound inequality form, we have 70 on the left, less than or equal to 75 plus 94 plus 95 plus x, all divided by 4, less than or equal to 79 as a setup of the compound inequality. And then we just simplify the numbers. As the left-hand side stay at 70, less than or equal to the sum of these three numbers, that is 264. So we're gonna get 264 plus x, all divided by 4, less than or equal to 79. And then multiply all three parts with the value 4. Multiply by 4, multiply by 4, and multiply by 4. The left-hand side, we get 280, less than or equal to, put the parenthesis value here, 264 plus x, less than or equal to 79 times 4 equals 316. Next step, we're gonna subtract 264 to all three parts. Then we get x in the middle as the fourth scores. The left number becomes 16. The right number becomes 52. So then the range of the fourth scores on the score of the fourth test of Lisa gonna be between 16 and 52 inclusive. The next example, a person inherits $36,000 with a stipulation that for the first year, the money must be invested in two stocks, paying 8% and 9% annual interest, respectively. What is the greatest amount that can be invested at 8% if the total interest earned for the year must be at least $3,090? The amount that this person has is $36,000. It will be split into two portions. One portion or one will go to the investment with the 8% interest. The other one will go with a 9% interest. So let's start with identify or define the unknown. The problem asks for the graded amounts that can be invested at 8%. So we're gonna let X be an amount invested in stock paying 8%. So that means the remaining, which is 36,000 minus X, will be an amount invested in stock paying 9%. So that means the interest or the total interest would be from the 8%, which is X, multiplied by 8%, which is 8/100, plus another amount, which is 36,000 minus X multiplied by 9%, or 9/100. Or you can use 0.09 and 0.08. And then the total interest for the first year must be at least means greater than or equal to 3,090. So the total interest here is greater than or equal to 3,090. Now we have the inequality problem as X times 8/100 plus 36,000 minus X times 9/100 greater than or equal to 3,090. Let's simplify the expression and then solve for X. Since all divided by 100, so starting with simplifying the expression by multiplying all by 100, so we get 8 times X plus 36,000 minus X quantity times 9 greater than or equal to 3,090, and then 2 more 0 because multiply all by 100. And next, we distribute the 9 into parentheses. We get 8X plus 36,000 times 9 is 324,000, and then minus 9X greater than or equal to 309,000. Then we have 8x minus 9x becomes negative 1x plus 324,000 greater than or equal to 309,000. Subtract both sides by 324,000. Then we get negative x greater than or equal to negative 15,000. And solve for x, multiply both sides by negative 1, or you can treat as divide both sides by negative 1. So the inequality symbols switch to opposite. Then we get x is less than or equal to 15,000, sorry. So that means the greatest amount that can be invested at 8% is $15,000. For this application of linear inequality, to qualify for gold status at Awesome Airlines, one must fly less than 14,400 miles, but at least 6,600 miles each year. If Greg takes a 300-mile round trip flight when visiting his parents, how many times does Greg need to visit his parents each year to attain gold status? Express your answer in interval notation. The problem asks for how many times Greg needs to visit his parents each year. So we're going to define the unknown. So let x be the number of times or number of the trips that Greg needs to visit his parents each year. So each trip he will earn 300 miles. That means the total miles each year gonna be 300 multiplied by x. The problem indicates that to qualify for gold status at Awesome Airlines, one must fly less than, so we just look at the key term, less than 14400. That means less than transfer into the mathematical notation. So less than, strictly less than 14400. Another key term, at least 6600. That means it's going to be greater than or equal to 6600. So the total mileage going to be combined with these two numbers using the appropriate inequality symbols. So we're going to set up the compound inequality for this problem. As the total mileage 300 times x less than or strictly less than 14400, and the total mileage going to be greater than or equal to 6600. After we get this compound statement or compound inequality, we are going to solve for x. So divide all three parts by 300. We have x in the middle, and 6600 divided by 300 is 22. 14,400 divided by 300 is 48. That means the number of times that Greg needs to visit gonna be the range of 22 and 48, including 22, not including 48, as an interval notation for this problem solution.